So let's look at this one that's a little bit more complicated, where we're going to change the sines and cosines to kind of help us move forward and to verify this identity. Again, not to solve, but to verify. So you go. Which side is more complicated, left or the right? I can work on the right and you work on the left? No, I'll work on the left, and you just stay focused on that secant of x. So what we're going to try to do is try to look for some different tools that we have over here in red that may help us move forward a little bit. So first of all, let's look at this tangent of x and see if I can go ahead and use an identity for that tangent of x. So I have sine of x. Tangent of x is also the sine of x over the cosine of x plus cosine of x. Now, I just want to give you a little bit of a warning, not a warning here, but a helpful thing. Let's don't get lazy and forget and omit the variables. We need to keep those variables along with us as well. We don't want to just write sine times sine over cosine plus cosine. We want to make sure we keep those variables involved in the process as well. All right, this looks like now I can multiply those two, and I got sine squared of x over cosine of x plus cosine of x. I have a sum. You've noticed that earlier. So in order to add terms, I need to have common denominators, and they're not right now. So let's multiply this one by cosine x over cosine x. And in so doing, I have sine squared, whoops, not a 2 yet, sine squared of x over cosine of x plus cosine squared of x all over cosine of x. Now I have common denominators, so I can add them. And so I have sine squared of x plus cosine squared of x all over cosine x. And now I want to see if I can remember another identity here. I've been just kind of reducing right now, but I have the sine squared x times the cosine, or plus cosine squared of x, and I seem to remember that I've seen that before. And if you seem to remember that you've seen it before, that's great. I don't care right now that you have to remember exactly what it meant or what it was. I'm pleased that you remember actually seeing that before. So let's look over our fundamental trig identities and see if we see this. And we do. It's part of our Pythagorean identities, where the sine squared of x plus cosine squared of x equals 1. I love when things equal 1, don't you? So let's rewrite that as, I'm going to go over here to the right a little bit. Now I'll go down one more. So this becomes 1 over the cosine of x. I love that. And 1 over cosine of x, that feels reciprocal to me. And so what was the 1 over the cosine of x? 1 over cosine of x is right here. And 1 over cosine of x, its reciprocal identity, was the secant of x. There you go, the secant of x. And that's what I was trying to do, is manipulate one side, usually the more complicated, all the way down to where I get the same statement or value on this side as I did on the right. And so I again verify that this is true, because I found out that this reduces down to the secant of x, and that equals the secant of x.